Hey, welcome back to the channel. Today we're going to be covering extending your network. So we're going to be learning about some of the technologies that are used to extend your network out into the internet. So we're going to start out with port forwarding. So this is an essential component in connecting applications and services to the internet. Without port forwarding, applications and services such as web servers are only available to devices within the same direct network. So as you see, same network, network 1, you bring in a second network, network 2, you have that port that opens it up, and everyone's getting into the internet. Um, so we have that. Yep. Port forwarding is configured at the router of a network. So that's the answer to the question. What is the name of the device? This is going to be your router. Okay. Firewalls 101. Firewall is a device within a network responsible for determining what traffic is allowed to enter and exit. So obviously, firewall wall controls what can go in, what can go out. Border security for network, exactly. Um, can permit or deny traffic from entering. Yep, pretty self-explanatory. Um, router, description, so stateful type of firewall, based upon the entire connection and stateless, static rules, whether or not individual packets are acceptable or not. These firewalls are great when receiving large amounts of traffic from a set of hosts. Okay. What layer of the OSI model do firewalls operate at? This answer is provided. I believe it is 2 and 3, which is going to be our data link in our network. No. 3 and 4. There we go. So this is going to be our network and our transport layer. Which I'm not sure if it specifically says that, but there you go. What category of firewall inspects the entire connections? This right here. This is going to be our stateful, not whatever that was, and individual packets is going to be stateless. Okay. Moving on to practical firewall. Deploy the static site. Malicious traffic are marked as packets in red. Legitimate traffic are the packets marked green. Protocol you need to block is port 80. Configure the firewall to prevent the malicious packets from reaching the web server 203.0.1.1.0.1. Okay, it's under attack. Let's stop it. So we need to stop here. It's trying to go here. We're going to stop on port 80 and we're going to drop it. So it's going to stop the firewall right here at this router. It's trying. So the source, here's the source, the destination. It is trying to go here. Port 80 configured on the router. And from there, we're going to drop the packets, which you were able to see. Now moving on to VPN basics. So VPN, virtual private network, or VPN for short, is a technology that allows devices on separate networks to communicate securely by creating a dedicated path between each other over the internet. Devices connect within this tunnel from their own private network. Okay, pretty self-explanatory. You can kind of get an idea here. I would say network 1, network 2, or network 3, sorry, and network 2. But then these are the VPNs that they're able to connect. And so let's go down. So he talks about some of the benefits of using a VPN. Offers privacy, huge. Yeah, definitely good to use VPNs. PPP technologies, the PPT allow for authentication and provide encryption of data. VPNs work by using a private key and public certificate similar to SSH. A private key and certificate must match for you to connect. PPTP, the point-to-point tunneling protocol, is a technology that allows the data from PPP to travel and leave a network. Easy to set up. IPsec, Internet Protocol Security, encrypts data using the existing IP framework. It's difficult, okay. With VPNs only encrypts from our we just said that. So PPP. And what VPN technology uses the IP framework? We just said that one as well. That's going to be your IPsec. That should load. It's not gonna. No. There we go. Okay. What is a router? It's a router's job to connect networks and pass data between them. It does this by using routing, hence the name router. So we can see there. What is a switch? So you have all these hooked up to a switch, which then goes to the router, which is then going to go out to the internet. And you kind of see it here. You have two different VLANs, virtual local area networks, and then they're all hooked up to the same switch. Different subnet and on each one, but it's the same physical device, which is then going to the router. And then, so what is the verb? This is going to be routing. And what are the two different layers of switches separated by a comma? So this is going to be layer 2 and layer 3. So this is layer 2, layer 3. Layer 2, layer 3. Okay. And then last but not least, we have our practical network simulator deployed to static. So let's open this up. Number of traffic, the simulator will break down every step as a packet needs to get from point A to B. Try sending a TCP packet from computer 1 to computer 3 to reveal a flag. So we're sending from 1 to computer 3, a TCP packet, and let's just send hi. Okay, send a packet. Okay. It's going, and some other one. There we go. Okay. We got this. Okay. So, how many handshake entries are there in the network log? Let's take a look, because this is going to keep going. Yep, because we're going to log that one too. So, start us here. 1, 2, 3, 4. Received. Handshake complete. So I know there was kind of confusing, but if you can read them, you can see that it's starting. It's in the send packet from 1 to 3. It's just going over the entire handshake. But there are 5 that are going through it, if you count them. Yeah, so that is all that. Woohoo! We just finished extending your network, which is the end of the networking fundamentals. So we are officially networking nerds. So moving on, we're going to work into how the web works, starting with DNS in detail. That'll be a good first one to kind of take a look at for sure. But anyway, hope to see you in that one. Please subscribe, like the video, helps me out, helps the channel, and hope to catch you next one. So thanks for watching. See you.